In this prototype, I want to model and solve an entire game of crossword given the shape of the board and using a provided dictionary. I will take my word list loading code from before, and I think I can probably work with that. And we'll take a look at the rest of this. So I know the loading of the word list is pretty straightforward. This is a little bit tricky. And the reason this is a little bit tricky is what you can think is our choice of word that we fill in is going to affect what our next set of choices of the words are going to be. I had a relative once who played the crossword puzzle every day of the week, including Sundays, and did it in pen. And I was so impressed because people who play the crossword puzzle in pen are very confident that they're never going to have to scratch something out and go back. I've always had to play it in pencil, and the most I've ever managed to get is like maybe 2 words, really the obvious ones. Here, what you can think is, if we're playing with a clue-free strategy, just a letter matching strategy, that is going to be tricky. We may be able to base that off of our core mechanism, namely the finding of the words just like this. And so here, that our core mechanism. What we might need to do is we might need to model the board. But we know what the board largely looks like. It's just a bunch of sequential spots. It's something like this. It's a bunch of patterns that we have, one for each row. That's one that we don't know. That's another one that we don't know. And that's another one we don't know. And if we have a very naive approach, then what we might do is we might pick possibilities for these and then assess whether those are valid, or we might pick a possibility for this and then assess this. So I guess as part of modeling this, we also need to know where things overlap. This is quite tricky for us to model. How do we model that we have these individual patterns and that this letter here is the same as that letter there? Well, in terms of the modeling, there's 2 general problems. One, how do we model it for a human being to enter? And one way that we can model for a human being to enter is if you think about it, if you used all lowercase and all uppercase letters, that's 52 possibilities. Are there more than 52 possible things in a small Scrabble game? Maybe not. So maybe you kind of code these as, the letters with the overlap. Actually, no, I guess that doesn't work either because it would be individual letters. So you'd have to do something like, I don't know, maybe visualize it. I don't know. It's quite tricky. It's probably not worth even thinking about that. It's probably presuming some sort of structure for this. So what I'm going to do is I'm going to take the same process that I took before. I'm going to try and map out what the API looks like. Because at the minimum, if I am faced with a problem that I don't know how to solve and I don't really have an intuition for where to get started, the thing that I can do is I can solve the parts that I'm able to solve. Designing the API might be something that I can at least make some headway in. Designing the incremental solver is something I can make headway in, but solving the overall problem may be a little bit beyond me. Here's what I know. I know that I want to have some sort of layout, and the layout is constructed from some sort of specification. I just don't know what that specification looks like. So I think, from data classes, import data class, I know that my starting point is almost guaranteed to be some kind of layout like this. I don't really know how I specify these, but I know I have that. I know for the layout, I have some mechanism for solving this. And I know that if I lift that solving, especially since it has this combinatoric perspective to it, it's going to be slow. So I know that I probably need to be able to write this in pure Python to prototype it and then drop down into C, the whole restricted computation domain idea. So I know that as part of the constraints of my API, it's not just what a user wants to be able to do. It's also where I can later hide optimizations by dropping down to the C layer, by describing an overall abstract process. So I think I actually want to do something like this. I want to be able to ask this thing for the possible solutions like this. So that once I discover that this is very, very slow, this method that I have here, I can actually drop down to the C layer and find some way to represent that. However, one of the problems with this whole restricted computation domain idea is I start to curtail my ability to give the user flexibility. Because why did I even bother doing this? I could have just done a class T that had a method called doIt that didn't take any parameters, and then all you can do is just do c.doit. Well, why do you even bother with the class in the first place? Just have a function that's called doit and then swap it out with the Python function. Really, the reason why we design APIs like this is to give somebody the flexibility to assemble pieces, not just to do data loading, not just to do the solving. And so one of the things that I really need to think about is, what are the pieces that an end user is going to want to slot in or control? And this, again, is quite tricky. Because what you can think is most likely for the game of crossword, it's not the scoring, because you don't get scored in the game of crossword. It's probably the strategy. So this should be something that takes a strategy. And how do I model that strategy? Well, naively, I might think that I might want to model that strategy as some sort of coroutine. So that, for example, this runs forever, taking the state of the board in as I go. And this thing kind of iterates and passes me the state of the board, then asks me what's your next choice and whatnot. But how do I do backtracking here? And again, this forces me to operate at the Python layer, which is also kind of tricky. So what I might need to do is I might need to say, you know what, the coroutine approach is not unreasonable, but what I'm yielding from this coroutine, or what the incremental thing that I'm working on, needs to be at much higher fidelity. It needs to be maybe to the degree of one possible solution. See, if I just make this something that just returns a solution, given the layout, I guess I can do that, but then you can code this in pure Python, so you take this and this gives you the layout. And so then this actually inverts my approach, because here I would do the strategy given a layout. And you can see there are a lot of considerations here. The lie of live coding is that there is one unique, obvious approach through any problem, even design problems, and there isn't. And you can see this problem is actually a stumper. There's a lot of dynamics that I need to try and figure out. There's a lot of choices I can make, and it may be very difficult for me to say, without just privileging one approach, this is the approach that I have. There's a lot of considerations of, well, maybe in a couple of days' time, I'm going to discover this isn't fast enough, and I don't want to rewrite everything from scratch. When you find that you are blocked by that, and you throw up your hands in frustration, and you're not sure where to get started, here is the truth behind all of this. You eliminate possibilities. It's really the only thing you can do. And either you eliminate possibilities to communicate those to other people and say, look, I had to pick a choice. This is what I'm going to pick. It's not going to be possible to do this. This is the direction I've taken. Or to at least eliminate things that you can consider to just try and whittle down your search space as much as possible. Generally, if I think about this, I need to eliminate as many possibilities that I can. I know that the angle that somebody is going to take in order to work with this library or this code is they're going to want to slot in their own strategies. I know that as part of the strategy, I need to be able to evaluate that strategy, but I generally evaluate that strategy holistically. I know the strategy is going to be based off of a layout, and the layout is where the clues are and how they're interlinked, but it may also involve a particular state of the game. And so probably, because you might have filled in some things, you only might come to this tool, after you already fill in the things you already know how to fill in. So it needs to take some state of the game. Does it need to solve this incrementally and say, oh, place this and then place this and place this? Well, the question is, if it could incrementally place words as we go, then what I could do from the outside is I could say something like, for clue and clues, give me the possible solution given this clue, and this would be some representative object whittling this down. Is that valuable? Well, to think about it, probably you're going to want to solve the game as a whole. But if I want to incrementalize this and look at one clue at a time, what I would then be able to do is be able to add in intermediary constraints on the clues. Like you manually solve 1, 2, 3, then you go through clue or the kind of layout, what you have, to solve 4, 5, 6. Then you come back to it and you say, okay, from here, what do I do next? So you could have some sort of hybridized human-computer play. Or you could have some sort of dynamic crossword where, I don't know, the board shifts how it looks over time. That's maybe a little bit weird, but maybe you can think that that's a possibility that you might assess. If that were the case, and I also wanted to benefit from a restricted computation domain idea, what I might need to do is I might need this to be something that is not material. It definitely can't be materialized, because if it's materialized, then I have to answer it. I have to drop back to the Python layer. But the looping is probably at the scope of the number of clues that I have, but it has this exponential fan out. So what this might need to represent is some possible strategies. I might need to do this. So it might need to be some sort of abstract representation of the possible solutions that I have. Ugh, this is very difficult to model. And then at some point, I might need to rasterize this. I might need to give somebody the choice to like actually go and pick which ones are available, or I might actually give them the ability, the rasterization can be expressed in Python by a materialization here. And then what this might need to take is some sort of possible solution that is represented as some sort of representative object that represents where in the large search space you happen to be. So what you would have is some sort of abstract theoretical search space of all the possibilities that you have for the board. And then what this represents is how you then whittle that down. But it doesn't actually materialize it because the memory usage for this is going to be quite high if you need to materialize everything given one clue in a giant board. And you might defer the materialization here. What you can see is that live coding is a process that you can take to make forward progress on code that you have, but it's not always that easy. And it's not always the case that I have an answer written off to the side and I can just read it to you. It is the case that there is, however, a deliberate process that you can use, even in the case of something very difficult like this, to at least make some methodical forward progress.